So today I'm going to discuss about Advanced Encryption Standard AES. Previously we have seen Data Encryption Standard, that is DES. So we have seen there are some drawbacks in DES, and later we have seen 2DES and 3DES. So now we are going to study about Advanced Encryption Standard. So Advanced Encryption Standard is also a block cipher encryption algorithm in which the block size is of 128 bits. As we have seen in DES, the block size was of 64 bits. So we have seen DES was not that much secure. Then 3DES comes in picture. And in 3DES, there was key size, key length is of 168 bit. And algorithm was same as the DES. The only difference is that operation repeats 3 times. So drawbacks of 3DES was it was sluggish in software. Algorithm was sluggish in software. Means it was very slow. And there are multiple repeated operations of software to do. So it was sluggish, it was slow to perform. And another disadvantage was it takes only 64 bit of block for encryption. So block size was of 64 bit. So after seeing these drawbacks, NIST National Institute of Standard and Technology decided to come with another algorithm, and that named it as Advanced Encryption Standard. So AES means NIST started looking for a replacement for DES, which would be called the Advanced Encryption Standard or AES. It NIST specifies some requirement, means like it should block size should be of 128 bits, and it also mentioned that it has different key size of like 128 bit of key size, 192 bit of key size, and 256 bits of key size. So by varying and maximizing the key size, the algorithm will be more secure. So first point, NIST has specified that is the block size should be of 128 bit. So in DES it was of 64 bit. Now in Advanced Encryption Standard, the block size is of 128 bits. Another specification required for AES is it is an open algorithm available to the public worldwide. So for securing for secure encryption, we need to publish that algorithm. So it was also specified by NIST. So they have called proposal from all over the world. And after the first AES candidate conference, NIST announced that 15 out of 21 received algorithm. Means they have received 21 algorithms, and in which they have announced that 15 algorithms satisfied all the specification data that were described by the NIST. And out of which they have selected 5 algorithms in second AES candidate conference, and it announced that 5 out of 15 candidates, means 5s are Mars, RC6, Raindown, Serpent, and 2 Fish were selected for the finalist in August 1999. Okay, so initially it was 21, then there's 15 qualified as per the specification, and out of 15, 5 selected for finalists. And after the third AES conference, NIST announced that Raindown, designed by Belgian researcher, John Damon and Vincent Regiment was selected as AES in October 2000. So finally, the Raindown algorithm is selected as AES algorithm. So NIST announced that Raindown algorithm, which was designed by Belgian researcher John Damon and Vincent Regiment, was elected as AES in October 2000. So AES algorithm, as we can see in this slide, so the size of data block is of 128 bit. AES algorithm have three different key size. One key size is of 128 bits, another key size of 192 bits, and another key size is of 256 bits. Based on the key size, there are different number of rounds. Hence, if key size is 128 bits, means there is number of rounds are 10. For 192, number of rounds are 12. For 256, number of rounds are 14. So A is the replacement of AES. So by increasing the key size, we will see in detail what are the operations performed on each round and what are the structure of AES. So in basically AES has three different configurations with respect to the number of rounds and key size. So this table we can see means 128 10 rounds, 192 bits 12 rounds, 256 of 14 rounds. AES uses 5 data units of measurement to refer to data. They are bits. Bits means binary digit with value 0 or 2. Second one is byte, a group of 8 bits. It can be a row matrix or a column matrix. Word, a group of 32 bits. Word is represented with small w. Block, a block in AES is a group of 128 bits. So it represented as a row matrix of 16 bytes. Row matrix of 16 bytes. State, before and after each stage, the block data block is referred to as state. Hence, that state represent before the operation and after performing the operation. So each before and after each stage, the data block is referred as state. So this binary it is 0 or 1. Second one was byte. Byte means it is collection of 8 bits. It can be a row. This represent the row matrix, and this represent the column matrix. So it is of 8 bits. Word is of 32 bits. So 32 bits we can write it as 4 bytes. So yeah, capital B. This B, this byte, this B should be capital. So words we represent as a W. So W, it is of 32 bits means 4 bytes. B0, B1, B2, B3. It can be also in terms of row, or it can be also in terms of column. B0, B1, B2, B3. It is of 32 bits. Block is it of 128 bits. So here B0 to B15. So a block in AES is of 128 bits. It represents the row matrix of 16 bytes. So one B0 contains 8 bits. So one B0 contains 8 bits. B0 contains 8 bits means B0 8 into 16. It's 128. So one B0 represents the 8 bits, and so here B0 represents the byte. So block contains 128 bits, and last one is state. State is of uh, also a size of 128 bits. State represent before and after each stage. Each stage means in every stage we are going to perform some operation. Means before that operation and after that operation, the data block is represented as a state. So state we can write it as S00 in S represent here S represent the state S00, S01, S02, S03, and so total 16. 16 means 16 into 8. Again 16 into 8, that is of 128 bits. So, or if we can write it as in 4 words. 4 words means one word represent 32 bits. 32 bits into 4. That is of. So either we can represent it as S0, S0, S01, or in W01, W0, W1, W2. So these are the basic data units which we are going to use, and see how operation are performed on these data units. So these are the basics. So AES. So if we talk about round, so there are different rounds are used based on the size of key. So first of all, AES non-fiesta system. So we have seen the AES was a fiesta cycle. So in this AES, if we talk about fiesta, so it is non-fiesta cipher that encrypts and decrypts a data block of 128 bits. So your block size is of 128 bits. Okay. It uses 10, 12, or 14 rounds based on the key size 128, 192, 256 will depend on the number of rounds. So if we are using 10 rounds, means the key size will be 128. If we are using 12 rounds, means key size will be 192. If we are using 14 rounds, means key size will be 256. So it is important question from objective point of view. So what are the rounds, number of rounds based on the key size? But we take different key size. But in AES, we always use 128 bits of key. So if I say about sub key, is that key we are going to use for encryption, that is always of 128 bits. Like in DES, we use key size of 64 bit, out of which we have removed parity bits, and left key size was 56 bit, and sub key size in DES was 48 bits. So out of 56, we use 48 bits only. In similar way, in AES, we use different key size 128, 192, 220. But that sub key we used in AES is always of 128 bits. So here we can see in diagram, we take input of 128 bit plain text, means we divide that plain text in is of size of 128 bits, not more than 128 bits. It's size of 128 bits. Like in AES, we have chosen size of 64 bits. One block size should be in AES, one block size should be of 128 bits. Then we will go pre-round transformation. We will see in detail what is pre-round transformation. Then round 1, round 2, and show that round NR. And there is a key expansion. So cipher can be used 128, 192, 256. And out of and for these rounds we use some keys, sub keys. It is always of 128 bits. Whatever key size we use, but that round key should be always of 128 bits. Okay, we will give input this of size of 128 bits key. And finally, after performing this number of rounds, we get 128 bit cipher text. So 128-bit plain text converted into 128-bit ciphertext in AES. Here NR represent number of rounds and key size represent the size of key in bits. So 10, 128, 12, 182, 14, 256. Is the relationship between the number of rounds and cipher key size. Okay. Okay, we have already seen state block. So insertion, one important thing. When we insert any plain text or any bits in a state, then insertion must be in column wise manner. Means first element B0, then B1, B2, B3. So it should not be B0, B1. It should not be row wise. It always should be column wise. Here we can see the diagram. Always should be column wise. B0, B1, B2, B3, then B4, B5, B6, B7, B8, B9, B10, B11, B12, 13, 14, 15. Same way, when we have state and we convert in the block, then we also read from row wise. Reading row wise. Sorry, read in column wise. B0, B1, B2, B3, B4, B5, B6, B7. So first column, then second column, then third column, then fourth. Let's see this example. Suppose we have a 16 character block can be shown in 4x4 matrix. Suppose our plain text is AES usage a matrix. So our given plain text is our given plain text is AES usage a matrix. Okay, this is our plain text. So total number of character if I count 1, 2, 3, I'm not counting the space character. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if consider in hexadecimal, so if we convert means if we map this plain text into 128-bit size, then we require minimum 16 characters. 16 into 8, that is 128 bits. So AES in AES the block size must be of 128 bits. So here total characters is of 14. Total character is total character is given plain text is 14. So we need to add 2 extra bogus character. So we use in this example it used 2 bogus character as ZZ. So now total characters are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Now it is of 128 bits. Now we replace each character with integer 0, 0 to 25. Means simply now we are going to put numbering. Means A 0, 0, B 0, 1, C 0 like this. So after putting this, yeah, or we can write it as A00 E04 in hexadecimal. So one uh, hexadecimal that we represent in 4 bit. So for 0 it is 4 times 0, and this for second 0 it is 4 times 0. Similarly for E04 means first 0 4 times 0 and 4 0 1 0 0. So 8-bit, each of the character are of 8 bits. So 8 bits into 16 characters, total 128 bits. So we can A00, E04, S12 like this. We have mentioned X23, Z19, Z19. Some random value is allotted. We can also 19 means if we convert one 19 means if we convert hexadecimal to that decimal, so 19 means 16 to the power means it is 25. So how to convert this block into a state? So this is B0, B1, B2, B3. So we put it as column wise. So first 0 0, then first we fill the first column. So 0 0, then 0 4 1 2 1 4, 0 0 0 4 1 2 1 4. Then next column 12 4 12 0 0, 12 4 0. Likewise, we convert from block to state. So hope it is clear how to convert block into state. So changing ciphertext to state.